Welcome to Rationalizing the Denominator. Rationalizing the denominator, let's review some vocabulary. To rationalize, that's the process of eliminating radicals from the denominator of an algebraic fraction. We remove the radicals in a fraction so that the denominator only contains a rational number. Remember, any non-perfect square or non-perfect cube is an irrational number, making it not a real expression. Therefore, the algebraic fraction will be compliant with the rules of being in simplest form. So for an algebraic expression to be in simplest form, there cannot be an unsimplified radical in the denominator. Today we will learn how to rationalize the denominator of an algebraic fraction by using a factor of 1 and also by using a conjugate. First, let's be learning how to multiply by a factor of 1. So we have the identity property of multiplication that we are going to employ while doing this, which states that when you multiply any value or expression by 1, the result is always equivalent to the original value or expression. So in simpler terms, you can multiply any value by 1 and it results that value. So let's start with the rational expression 6 divided by the square root of 2. This is not in simplest form because the denominator contains a radical. We can't simplify the square root of 2 just by finding the square root of 2 because it's irrational. There isn't a number it equals. It's a non-repeating, it is a non-patterned repeating decimal. So you'd round it. It would not be equivalent. So we're going to use the identity property of multiplication. And we're going to pick this factor of 1. The square root of 2 over the square root of 2 is equivalent to 1. So we're multiplying by a factor of 1. So we can multiply this using the identity property of multiplication. Now, I picked the square root of 2 divided by the square root of 2 because that will now make the denominator a perfect square root. The square root of 2 times the square root of 2 is the square root of 4, which is equivalent to 2. Then our numerator has 6 times the square root of 2, which is okay. But following the rules of the simplest form, you can have a radical in your numerator, just not in your denominator. So we've multiplied, and then there's one last step we need to simplify. 6 divided by 2 is 3. So our final answer in simplest form is 3 square root of 2. So once again, this rational expression, 6 divided by the square root of 2, in simplest form, is 3 square root of 2. Your turn. I would like you to simplify the expression below using the identity property of multiplication, multiplying by a factor of 1. Please pause, come back and hit play when you're ready to check your work. Welcome back. Let's review your solution. So I multiplied by a factor of 1, which was the square root of 3 over the square root of 3, to force the denominator to be a perfect square. So when I multiply, I get 7 square root of 3 divided by the square root of 9. Square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3, and there we have our simplest form. 7 square root of 3 divided by 3. You can also use this to rationalize denominators with cube roots. So we're still going to use a factor of 1. However, now we're going to consider what factor of 1 we will need to multiply to create a perfect cube. When you're doing square roots, it's easy because it's whatever you have in your denominator, you multiply it by itself and it creates a perfect square. This is not going to be the case for perfect cube. So here's our first expression. 1 divided by the cube root of 2. So now I'm going to multiply by the cube root of 4 because when I multiply, I have 1 2 here and 2 2's here, and I'm looking for a set of 3 factors. So the cube root of 2 times the cube root of 4 is the cube root of 8, which is a perfect cube. So then I need to consider that I need the factor of 1. So my factor of 1 is going to be the cube root of 4. So when you're doing a cube root, when you're rationalizing a cube root in the denominator, you need to consider two things. You need a factor of 1, but you also need to create a perfect cube. So now I'm going to multiply. 1 times the cube root of 4 is the cube root of 4. The cube root of 2 times the cube root of 4 is the cube root of 8. Now we want to simplify. The cube root of 8 is 2. So in simplest form, this rational expression, 1 divided by the cube root of 2, is equivalent to the cube root of 4 divided by 2. Your turn. Try simplifying the expression. Hit pause and come back and hit play when you're ready to check your work. Welcome back. So, to create our perfect cube, I had 2 3's here, and I multiplied by the cube root of 3 to create the cube root of 27, which is a perfect cube. So again, we're looking for sets of 3 factors to make a perfect cube. 2 3's, I needed an additional 3, so I multiplied by my factor of 1 was the cube root of 3 divided by the cube root of 3. Multiply the numerators, 18 times the cube root of 3, all over the cube root of 9 times the cube root of 3 is the cube root of 27. The cube root of 27 is 3. It's a perfect cube. We have one more step. 18 divided by 3 can be simplified. So the final answer is 6 cube root of 3. Now let's talk about conjugates. Sometimes we're going to have an expression that you cannot use the factor of 1 method. We're going to have to use conjugates. What is a conjugate? A conjugate is a mathematical value or an entity having a reciprocal relation with another. They have opposite signs. So let's just look at this. You're all used to seeing emojis. These are conjugates because they have opposite relationship. One's smiling, one's frowning. They are conjugates in a symbolic world. Mathematically, we're going to talk about conjugates being opposites, being add, or an expression with subtract or with add. So they undo each other. We've talked about this a lot. Subtraction undoes addition, addition undoes subtraction. They are opposite signs. So we're going to focus on addition and subtraction when we talk about forming our conjugates. One other thing we need to review before we start rationalizing denominator using a conjugate. I want you to remember the sum and difference pattern when we talked about factoring and multiplying polynomials. We talked about a plus b being the sum multiplied by the difference a subtract b, and they had a very unique relationship. You could FOIL or use the table method, vertical or horizontal, whatever pattern, whatever method you use, but you would get a squared minus ab plus ab minus b squared. When we simplify, we end up with a squared minus b squared, knowing that a plus b multiplied by a subtract b is equivalent to a squared minus b squared. So this is what we call the sum or difference pattern. These are also conjugates. A plus b and a minus b are conjugates. And we're going to use this idea and this method to rationalize denominators. So here we have our first expression. We have 3 plus the square root of 5. And to rationalize this denominator, we want the conjugate of 3 plus the square root of 5. The conjugate would be 3 subtract the square root of 5. These are conjugates. Then we have our factor of 1 because we can multiply anything by 1 using the identity property of multiplication. So we have our original expression, fraction. We found our conjugate of our denominator, and we created a factor of 1. Now we want to multiply. 4 times the value 3 subtract the square root of 5. I would strongly encourage you to wait to distribute until the end, because often before you've distributed, we can simplify using this factor. I'll show you that in a second. Then using our sum and difference pattern, we know that these are conjugates, so we take 3 squared is 9. The square root of 5 squared is 5. So the square root of 5 times the square root of 5 is the square root of 25, which is 5. So again, using this conjugate, we've created a perfect square for that second term. So we end up with 9 subtract 5. So we simplify by, first I'm just showing you the denominator. We're simplifying first. 9 subtract 5 is 4. And then I want you to note the reason that I suggested that you don't distribute the 4s because now it makes it easier to simplify. We have a factor of 4 in the numerator and a factor of 4 in the denominator, and 4 divided by 4 is 1. So when I simplify that last step, I end up with 3. Subtract the square root of 5. Your turn. I'd like you to simplify this expression using a conjugate. Go ahead and hit pause. Come back and hit play when you're ready to check your work. Welcome back. So I found my conjugate, the square root of 2 plus 2, created my factor of 1, multiplying, leaving my distributive property here while I simplified. The square root of 2 times the square root of 2 is 2. Negative 2 times 2 is negative 4. Simplify your denominator and you get negative 2. Once again, we can see we can simplify. 4 divided by negative 2 is negative 2. Now for the final step, you'll distribute. Negative 2 square root of 2, subtract 4. Thank you for joining me today.